Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Walker Grant Middle School. And for the probability exit ticket, let's try that word again. Numero dos, so number 2. It says Greta has 2 bags of tiles that are all the same size and shape. It says it has bag A and bag B. So I'm actually going to go ahead and kind of draw out what that looks like. So it have, I'm going to use U for blue, and I have 1, 2, 3 green. So this is kind of its own bag here. And now the bag, so this is bag A, and then bag B. So we're going to say bag B. Kind of looks like this. We're going to say as 1, 2, and then it has how many black ones? So 1, 2, 3, 4. All right. You're going to always want to draw that out. It doesn't have to look perfect, but as long as you're able to kind of visibly see it, it makes it a lot simpler. So it says, which of these best describes a dependent event? Again, that's saying this. It does affect the outcome. The outcome. Meaning, if I take something out, it is going to change how many are left. So the dependent events do change the denominator. And so we're going to say, all right, well, if you read some of these carefully, you can kind of see how these work. So let's see. It says randomly selecting one tile from bag A. So I would take one of these out, and then replacing it, then selecting another tile from bag A. So it would be decent since we are, or dependent, I should say, since it's in the same bag. However, since we are replacing it, that means that it's independent. So it's that we're going to say that this is independent. So it can't be that one. All right. So let's see. It says randomly selecting a bag from bag A, replacing it, and same idea. Since it says replacing it, we already know it is independent. And also too, since we're taking from one from each bag, it's not going to affect one another. Meaning, if I take one of these green ones from bag A, is it going to change the number of tiles in bag B? Well, it's not, and so we know those are 2 different ideas. And so we can use that for this bottom one here. It says picking from bag B, not replacing it, and then picking from bag A. So even though it says not replacing, that usually is dependent, since it has that these are 2 different bags, this would also be independent. This is a rare case, but again, you're saying that since they are not affecting each other, you know it is dependent. And so the only one left, again, we eliminate our answers, and so we said that randomly selecting one from bag B, not replacing it, and then selecting again from that same bag. So again, if we were to take a black one from bag B, it changes the total number and the number of black tiles that are in there. Since it does change the outcomes, we know it is dependent. So it is this one. Okay, so now let's say, and I probably should have typed this in here for you guys, but because it came up a lot. Let's say you put all these tiles together. So let's do that down here. Let's say I have a blue, a green, yellow. I got 1, 2, 3, 4. All right. Let's say you put them all in one pile. How many in total do you have? Well, I have 10 total. 10 total. Again, you want to say what's the probability of selecting yellow, not replacing it. So right away, if it's all from the same pile, this makes it dependent. And then selecting a green. So we're going to find the probability of picking yellow. Well, how many yellow are there? We have 2. How many total? 10. And you can simplify this fraction to 1/5. again, you take that one yellow out. So again, you can cross that out. And so we say we take one yellow out. How many do we have left? Well, we have 9 remaining. 9 remaining. So when we go to find how many, what would be the probability of picking a green, it's probability of picking green, but it's after. So let's say probability of picking green after we took a yellow out. Again, that after tells us that we are doing a dependent event. We are changing that original amount. So again, we had 9 remaining. How many are green? Well, only 3 are green. Again, we can simplify this to be 1/3. Again, make sure that you see and tells us that we need to multiply. And so let's do that at the very end here. So we're saying probability of picking a yellow and a green is going to be those two multiplied together. So we have 1/5 times 1/3. That's going to be 1/15 as your simplified fraction. And let's see what you end up getting. It's going to be that 0.06 repeating. Again, you want to make sure you round to the nearest 100th, and so that would be about 7%. Again, make sure you're reading these carefully for yourself.